What are mathematical sculptures?
Mathematical sculptures are sculptures that represent some mathematical design. They are usually a geometrical figure and can be made of materials such as metal, wood, concrete, or stone shaped into squares, triangles, cylinders, specific curves, rectangles, spirals, and so on. Many of these sculptures represent different mathematical concepts. From polyhedral geometry and topological knots to fractal designs.
What is a lunar-based calendar?
A lunar calendar is a calendar based on the orbit of our moon. The new moon, when you can't see the moon because it is aligned with the sun, is usually the starting point of a lunar calendar. From there, the various phases seen from Earth include crescent, first quarter, and gibbous. These phases after a new moon are also labeled waxing, such as waxing crescent. When the entire face is seen, it is called a full moon. From there, the phases are seen in reverse, and are labeled waning, such as waning crescent. Overall, the entire moon cycle takes about 29.530589 days. This cycle was used by many early cultures as a natural calendar.
What is a universal set?
A universal set actually applies to sets that are not universal but are chosen from a specific type of entity, such as sets of numbers or letters. Thus, the set of all the elements in a set theory problem are collectively called the universal set. In reality, however, the set of all things does not exist because there is no largest or all-inclusive set. And so the true universal set is not recognized in standard set theory.
How has applied mathematics changed over the past few decades?
In the past few decades, applied mathematics has made tremendous strides in explaining our world. In particular, with the advent of more powerful computers and their mathematically driven software from linked computers over a network to supercomputers, many disciplines that use applied mathematics have greatly advanced. For example, the use of giant wind tunnels to examine wind flow over aircraft only a few decades ago has been replaced by computer simulation. Now the design and testing of aircraft is accomplished by these simulations, making the expense of building physical prototypes a thing of the past because it is now merely a matter of mathematically drawing the aircraft on the computer in order to test new designs.
What is the concept of bound?
Similar to sequences, see elsewhere in this chapter, in calculus bounds are divided into the upper, either greater than or equal to every other number in a set of numbers, or greater than or equal to all the partial sums of a sequence, or lower, less than or equal to every other number. The symbol for infinity, OO, is used to denote a set of numbers without bound, or that increase or decrease to infinity. In calculus, the bounds can be divided even more into greatest or least. For example, the greatest lower bounds and least upper bounds are of special interest to calculus, as those numbers may or may not be found within a set.
What was the problem with the lunar-based calendars?
Nothing is perfect, especially a lunar month. The biggest drawback with using a lunar calendar is the fractional number of days, which makes a lunar calendar quickly go out of sync with the actual phases of the moon. The first month would be off by about a half a day, the next month a day, the next month a day and a half, and so on. One way to help solve the problem was to alternate 30 and 29-day months. But this, too, eventually made the calendars go out of sync. To compensate, certain cultures added intercalations, or subtracted extracalations, days from their calendar. For example, for more than 1,000 years, the Muslims' lunar calendar has had an intercalation of 11 extra days over a period of 30 years, with each year being 12 lunar months. This calendar is only out of sync about 1 day every 2,500 years. To see this, mathematically speaking, the average length of a month over a 30-year period is figured out with the following equation. 29.5 x 360 plus 11/360 equals 29.530556 days, in which 11 is the number of intercalated days. 360 is the number of months in a 30-year cycle, 12 months x 30 years. And 29.5 is the average number of days in the calendar month, or 29 plus 30/2.
Why are some prefix names different in measurements?
The main reason why a prefix name would differ has to do with pronunciation and vowels. If the first letter of the unit name is a vowel and the pronunciation is difficult, the last letter of the prefix is omitted. For example, a metric measurement of 100 aries, 2.471 acres, is a hectare, not hectare, and 1 million ohms is a megohm, not megaohm. There are exceptions, though, especially if the resulting prefix and unit sound fine, such as a milliampere. There are even times that another letter is added to make it easier to roll off the tongue. For example, the letter L is added to the term for 1 million ergs, making it a megalerg, not a megaerg or megerg.
What is the Dewey Decimal System?
The Dewey Decimal System of classification is a numerical method libraries used to classify nonfiction publications into groups based on subject. It was invented by American librarian Melville Lewis Kossuth Dewey. 1851 to 1931, as a system for small libraries. The subject of a book is classified by a 3-digit numeral that represents 10 classes of subjects, 000-999. In order, these are generalities, philosophy and psychology, religion, social science, language, natural science and mathematics, technology, applied sciences, arts, literature, and geography and history. For example, the handy math answer book would be found in the Dewey Decimal System under the 500s for natural science and mathematics. A Dewey Decimal classification number is followed by the Cutter number, or Cutter. This method was invented by Charles M. I. Cutter, 1837 to 1903, and is an alphanumeric way to represent words or names by using one or more letters followed by one or more Arabic numerals used decimally. Both systems, the Dewey Decimal System and Cutter, are together called the call numbers. A way of locating every book in a library.
What is money?
Actually, money is a mathematical concept. In each culture, money, or currency, is the most common medium of exchange. And through an agreement within a community it can be traded and exchanged for goods, services, or obligations. Each type of currency represents specific units that can be subdivided, such as dollar bills and quarters. A good or service is then given a certain value when compared to other goods and services. What is usually referred to as a price. Because of this, people who use money need to know some of the most basic of mathematical concepts, especially addition and subtraction. Of course, money is actually an abstraction. Now and over the centuries, it has been essentially a token. That is why money has often been represented by such things as naturally scarce precious metals, such as gold and silver, conch shells, trinkets, and today's entirely artificial representation of money, paper banknotes.
What is a graph?
The term graph has several different meanings in mathematics. It can mean the interpretations of numbers, including bar graphs, pie charts, and line graphs. For example, a pie chart, graph, is often used to represent percents, such as a breakdown of where a taxpayer's money is spent in the various government agencies for a certain year. In analytic geometry, a graph is simply a way of plotting, thus, visually representing points, lines, curves, and solids in order to understand and interpret certain geometric figures and to solve equations. For example, solving an equation with 1 to 2 variables, usually written as x and y, or 2 dimensions, results in a curve on a graph. Note, a line is considered a curve in geometry. Equations that contain 3 variables, usually as x, y, and z, or 3 dimensions, result in a surface.
How is mathematics used to describe population growth of organisms in a certain environment?
In general, a certain population of organisms from rabbits to humans will grow exponentially if it is left unchecked. That means that in a perfect world a population's rate of increase is constant. This can be seen in the following equations: after 1 year equals p0, 1 plus r. After 2 years equals p, 1 plus r, 2. After 3 years equals p, 1 plus r, 3. After n years equals p, 1 plus r, n, in which p0 is the population today and r is the rate of increase. These equations are further modified for population growth statistics. But such intricate calculations are not within the scope of this book. For more about population growth and biology, see above.
What is division?
The word divide comes from the Latin root vidua, referring to a separation. The word divide shares its major root with the word widow, and di, a prefix that is a contraction of dis, meaning apart or away. In division, the number being divided is called the dividend, while the number dividing it is called the divisor. The end result is called the quotient. For example, in 20/5 equals 4, 20 is the dividend, 5 the divisor, and 4 the quotient. Division in mathematics is a relatively new concept for the masses. It was only taught at university levels after the 16th century. The first to offer division to the public was German mathematician Adam Riese. 1492 to 1559, also seen as Ries, or Ris, in his work Rechnung nach der Länge. Auf den Linehan VND, Sick, Feder, often shortened to Practica. His work reached more people for an important reason: instead of the usual practice of writing a mathematical book in Latin, he wrote his book in German, thus reaching a wider audience.
What are identity and conditional equations?
Identity and conditional equations are ways in which numbers associate with each other. When an equation is true for every value of the variable, then the equation is called an identity equation. It is often denoted as I or E, the E is from the German Einheit, or unity. For example, 3x equals 3x is an identity equation, because x will always be the same number. 0 is the identity element for addition, because any number added to 0 does not change the value of any of the other numbers in the operation, or x plus 0 equals x. The number 1 is the identity element of multiplication. As any number in an operation multiplied by 1 does not change the value of that number. Multiplication identity is often written as x(1 equals x). When an equation is false for at least one value, it is called a conditional equation. For example, 6x equals 12 is conditional because it is false when x equals 3, and any number other than 2. In other words, if at least one value can be found in which the equation is false, or the right side is not equal to the left side, then the equation is called a conditional equation.
What does an equal sign represent?
In standard arithmetic terms, the equal sign, smiley face, is a symbol that represents two amounts with the same value. For example, 7 equals 7, or 3 plus 4 equals 7. When something is not equal, the sign is asterisk. As in 2 asterisk 3 or 3 plus 7 asterisk 12. In a line of computer code, the equal sign can mean something much different. For example, for codes used under certain conditions, such as a JavaScript reading computer, a single equal sign in a line of script means is. There is even a double equal sign, equals, smiley face, that means is equal to. An important difference when writing code for the computer. In addition, and confusing as it may seem, the computer codes for not equal are different, and include equals and slash equals.
How does one interpret sets?
There are several ways to look at sets. Two sets, or more, are considered identical if, and only if, they have the same collection of objects or entities. This is a principle known as extensionality. For example, the set A, B, C is considered to be the same as set A, B, C. Of course, because the elements are the same, the set A, B, C and the set C, B, A are also the same, even though they are written in a different order. It becomes more complex when sets are elements of other sets. So it is important to note the position of the brackets. For example, the set A, B, C is distinct from the set A, B, C. Note that the brackets differ. In turn, the set A, B is an element of the set A, B, C. It is a set included between the outside brackets. Another example that shows how sets are interpreted includes the following. If B is the set of real numbers that are solutions of the equation x2 equals 9, then the set can be written as B equals x. x2 equals 9, or B is the set of all x such that x2 equals 9. Thus B is 3, minus 3.
What is information theory?
Information theory is a branch of the mathematical theory of probability and statistics, allowing it to quantify concepts of information. It was formulated primarily by American scientist Claude E. Shannon, 1916 to 2001, who was also called the father of information theory, to explain the aspects and problems inherent in information and communication. In particular, it involves efficient and accurate storage, transmission, and representation of information, such as the engineering requirements and limitations of communication systems. Note: information theory has nothing to do with library and information science or with information technology. In information theory, the term information is not used in the traditional sense. Here it is used to mean a measure of the freedom of choice with which a message is selected from the set of all possible messages. Because it is possible for a string of nonsense words and a meaningful sentence to be equivalent. With respect to information content, information in this sense takes on a different meaning.
What are some divisions of polygons?
There are two major divisions of polygons. Regular polygons are convex polygons with equal sides and length. Thus, all sides and angles are congruent, equal. For example, one of the most famous regular octagons is the stop sign used along roads in the United States. A closed polygon with 8 equal sides. The naming of the various polygons can be challenging, though. For example, a polygon called a regular triangle is also called an equilateral triangle. Another name for the polygon called a regular quadrilateral is a square. Irregular polygons are those with sides of differing lengths and variable angles. Therefore, unless all the sides of the polygon are of the same length and all the angles are of the same measure, the polygon is said to be irregular. But don't be fooled, the names for the various polygons such as hexagon, nonagon, and pentagon, depending on number of sides, don't just apply to the regular polygons, but rather to any two-dimensional closed figure with the number of sides as described by its name. For example, the two figures shown above are both pentagons. A is a regular hexagon and B is an irregular hexagon. Polygons are described in other ways, too. Convex polygons are those in which every line drawn between any 2 points inside the polygon lie entirely within the figure. Opposite from the convex polygons are the concave polygons, those that are essentially caved in, with some of the sides bent inward. If a line is drawn between 2 points inside a concave polygon, the line often passes outside the figure. Another type of polygon is a star polygon, in which a star figure is drawn based on equidistant points connected on a circle.
What is a base in algebra?
The base is used in algebra in connection with powers. In fact, it is called the base of a power or the number that is used as a factor a given number of times. In the example 34, 3 is the base. The base can either be the number used with an exponent to create a power, such as the 3 in 34, or a number written as a subscript, such as with a logarithm, for example, log x, in which a is the base number. See below for more information about logarithms. For more information about bases, see Math Basics.
What does it mean when a test score is marked on the curve?
A test score marked on the curve means that the marks will roughly follow what is often called a Gaussian probability distribution or, more commonly, a bell curve. This symmetrically shaped curve is based on the test scores of the exam. In a perfect world, 1/6 of the scores would be on either end of the curve, with more than 2/3 falling in the middle, creating a normal distribution. But most test results are not ideal. Thus, when a plot of the number of students versus the marks received are viewed, the relative difficulty of the test is known. It is then up to the teacher to decide how to distribute the grades. This is usually done by comparing each student's mark to the distribution curve. The teacher then decides where to cut off the passing and failing marks, which is often referred to as curving the grades. For more about normal distribution, see Applied Mathematics.
Are ratio and proportion important in cooking?
Yes, ratio and proportion, two major mathematical concepts, are important in cooking, as is addition, subtraction, multiplication, and division. For example, when a recipe calls for 1 cup of flour and 2 eggs, the relationship between these two quantities is called a ratio. In this case, the relationship of cups of flour to eggs is 1 to 2, or 1/2, or 1 to. Any change in this ratio and the recipe's result will not be the same, and the food might not be edible. Another way of looking at cooking and mathematics is when changing the amount of ingredients in a recipe. For example, when a recipe calls for a certain amount of each ingredient, and the cook wants to make half a recipe, everything in the list is divided in half. 2 cups of sugar becomes 1 cup, 1/2 teaspoon of vanilla becomes 1/4 teaspoon, and so on. The same logic applies if the cook wants to double the recipe. But in this case everything is multiplied by 2. 2 cups of sugar becomes 4 cups, 1/2 teaspoon of vanilla becomes 1 teaspoon, and so on.
What is optimization?
Optimization problems deal with the point at which a given function is maximized, or minimized. It is divided into several subfields, depending on the form of the objective, function and the constraints that the maximized point often has to satisfy.
What do the numbers on gas and electric meters measure?
Gas and electric meters measure the daily gas or power usage, usually of a house or other building. The standard electric meters are clock-like devices that record the amount of usage. As a house or business draws on the electric current, a set of small gears inside the meter move. The number of revolutions are recorded by dials in the meter, with the speed of revolutions determined by the amount of power consumed. Newer digital models record power usage digitally. A gas meter measures the amount of gas used by a home or business. In this case, the meter measures the force of the moving gas in the pipeline. The dials on the meter turn faster as the flow of gas increases, or slower as the gas flow decreases. To understand how the gas and electric companies charge a customer takes only an understanding of simple mathematics. In both cases, the difference between 1 month's reading and the next month's reading is the amount charged. For example, if the electric current reading is 3,240 and the previous month's reading is 3,201, the amount of electricity used is 39 kilowatts for 1 month. Then the company multiplies the number of kilowatts by the amount per kilowatt hour to arrive at the charge to the customer.
How was the standard foot determined?
Whatever the true story, the foot we are familiar with today is equal to 12 inches, 30.48 centimeters. The true standardization of the foot came late in the 19th century. After the United States and Britain signed the Treaty of the Meter. In this treaty, the foot was officially defined in terms of the new metric standards being adopted overseas. In the United States, the Metric Act of 1866 further defined the foot as equal to exactly 1200/3937 meter, or about 30.48006096 centimeters. This unit of measurement is still used for geodetic surveying purposes in the United States, and is called the survey foot. By 1959, the United States National Bureau of Standards redefined the foot to equal exactly 30.48 centimeters, or about 0.999998 survey feet. This definition was also adopted in Britain by the Weights and Measures Act of 1963, thus, a foot, or 30.48 centimeters, is also called an international foot.
What is bioinformatics?
Bioinformatics is a field that evolved by joining biology and information science. In the past few decades, advances in molecular biology and the increase in computer power have allowed biologists to accomplish tasks such as mapping large portions of genomes of several species. For example, a baker's yeast called Saccharomyces cerevisiae has been sequenced in full. Humans have not been exempt, either. The Human Genome Project was completed in 2003. It determined the complete sequence of the 3 billion DNA subunits, bases, for humans, identified all human genes, and made all the associated information accessible for further biological study. Since that time, other universities and agencies have taken on the task of analyzing the results, such as determining the gene number, exact locations, and functions. Such a deluge of information has also made it necessary to store, organize, and index all the sequence data, which is where information science, or the method to store and work on such large amounts of data, comes in the form of bioinformatics. The computer experts who deal with such information are known as bioinformatics specialists.
What is cryptography?
Because of the extensive connections between computers across the Internet, it has become necessary to find ways to protect data and messages from tampering or reading. This includes protecting people's personal information when they buy things over the Internet and those who need to keep banking data secure. One of the major techniques for ensuring such privacy of files and communications is called cryptography. Cryptography is a mathematical science used to secure the confidentiality and authentication of data sent by a user to a certain site. It secures the data by replacing it with a transformed version that can then be reconverted to show the original data, but only by someone with the correct cryptographic algorithm and key. This is why, when ordering over the Internet, it is important to see the lock icon at the bottom of the screen. This is your way of knowing that cryptography is working and the data is secure, thus preventing the data's unauthorized use.
What is combinatorics?
Combinatorics is a branch of mathematics overall, called combinatorial mathematics, that studies the enumeration, combination, and permutation of sets and the mathematical relations that involve these properties. Defined as, enumeration sets can be identified by the enumeration of their elements. In other words, determining, or counting, the set of all solutions to a given problem. Combination is how to count the many different ways elements from a given set can be combined. For example, the two combinations of the four set A, B, C, D are A, B, A, C, A, D, B, C, B, D, C, D. Permutation is the rearrangement of elements of a set into a particular order, often in a one-to-one correspondence. The number of permutations of a particularly sized set with n members is written as the factorial n. For example, a set with 4 members would have 4 in first place to 1 in the last place. This would equal 4x3 x2 x1 equals 4, or 24, permutations of 4 members. For more information about factorials, see algebra.
What is a normal distribution?
A normal distribution is an idealized view of the world, producing the familiar, symmetrically shaped bell-shaped curve. It is usually based on a large set of measurements of one quantity such as weights, test scores, or height, which are arranged by size. In a normal distribution, more than 2/3 of the measurements fall in the central region of the graph. About 1/6 of them are found on either side. Many of us are familiar with the normal distribution from standardized school test scores, as most result in a bell-shaped curve, with students hoping to at least fall in the middle of the curve.
What are the connections between logarithms and algebra?
Logarithms are the numbers of the power to which a base must be raised in order to get a given positive number. For example, the logarithm of 100 to the base 10 is 2, or log 10 100 equals 2. This is because 10 equals 100. Common logarithms are positive numbers that use the number 10 as the base. They are written as log x. Those using the number symbolized by e as the base are called natural logarithms, also phrased as logarithms with a base e. The natural logarithm of a number x is written as ln x.
What is biology?
Biology is the science of life. It includes the study of the characteristics and behaviors of organisms. How a population, species, or individual comes into existence and evolves. And the interaction of organisms with the environment and each other.
What is Sangaku?
Sangaku, literally, mathematical tablet, and often seen as san. Gaku is the name for a form of traditional Japanese temple geometry. From 1639 until 1854, Japan was isolated from the West. Because of this, Japan developed a kind of native mathematics that was used by samurai, merchants, and farmers. They would solve geometry problems, marking their work on delicately inscribed, colored wooden tablets that hung under the roofs of shrines and temples. In general, Sangaku problems dealt with Euclidean geometry. But they were much different from Western geometric studies. Although the majority of the Sangaku are simple to solve by Western standards, others require the use of calculus and other complex methods.
What is a subset and proper subset in set theory?
Simply put, a subset is a portion of a set. If set B is a subset of set A, then all elements of set B are also elements in set A. If A and B are equal, then both sets are subsets of themselves. The empty set is also considered a subset of every other set. A proper subset is a subset other than the set itself.
How are vectors used?
Any physical quantities, especially those in association with mathematics and science, can be represented by vectors, such as force, velocity, and momentum. In specifying these quantities, one must state not only how large it is but also in what direction it acts. Even more complex is the use of multidimensional vectors for such problems as relativity, wind velocities in an atmosphere, and in determining electromagnetic fields. A row vector is usually used for problem solving in which a vector is described as v equals x, y, z, during the specification of a problem. But note, row vectors should not really be used with any mathematical descriptions.
What did the Chinese add to the study of mathematics?
Despite the attention the Greeks have received concerning the development of mathematics, the Chinese were by no means uninterested in it. About the year 200 BCE, the Chinese developed place value notation. And 100 years later they began to use negative numbers.
What are some characteristics of numerical analysis methods?
Characteristics of numerical analysis methods include accuracy. The numerical approximation should be as accurate as possible. Robustness. The algorithm should be able to solve many problems and should relate to the user when the results are inaccurate, and speed. The faster the computation, the better the method.
What were the major reasons for 16th century advances in European mathematics?
There are several reasons for advances in mathematics at the end of the Middle Ages. The major reason, of course, was the beginning of the Renaissance. A time when there was a renewed interest in learning. Another important event that pushed mathematics was the invention of printing. which made many mathematics books, along with useful mathematical tables, available to a wide audience. Still another advancement was the replacement of the clumsy Roman numeral system by Hindu-Arabic numerals. For more information about the Hindu-Arabic numerals, see Math Basics.
What other significant mathematical contributions did the Babylonians make?
Throughout the centuries, the Babylonians made many mathematical contributions. They were the earliest people to know about the Pythagorean theorem, although it was not known by that name. In fact, Pythagoras, in his travels to the east, may have learned about the theorem that would eventually carry his name from the Babylonians. In addition, the Babylonians possessed all the theorems of plane geometry that the Greeks ascribed to Thales, including the theorem eventually named after him. They also may have been the most skilled algebraists of their time, even though the symbols and methods they used were much different than our modern algebraic notations and procedures.
What is statistical mechanics?
Statistical mechanics applies statistics to the field of mechanics, the motion of particles or objects when subjected to a force. It is used to understand the properties of single atoms and molecules of liquids, solids, gases, even the individual quanta of light that make up electromagnetic radiation, to the bulk properties of everyday materials. Because statistical mechanics mathematically helps to understand the interactions between a large number of microscopic elements, it is used in a wide range of fields. In a way, it is also the opposite of thermodynamics, which approaches the same types of systems from a macroscopic, or large-scale, point of view.
Are there other ways of describing polynomials?
Yes, there are other ways to describe polynomials. In particular, a polynomial with only one variable is called a univariate polynomial. A multivariate polynomial is one with more than one variable. There are other terms to further define polynomials, including the following. Monomial. A monomial is a one-term polynomial, mono means one. For example, 3x is monomial. Binomial. A binomial is a two-term polynomial, bi means two. For example, 3x 210 is a binomial. Trinomial. A trinomial is a three-term polynomial, tri means three. For example, 4x3 plus 3x plus 6 is a trinomial.
What is a proposition in mathematical logic?
A proposition in mathematical logic is a statement that can be proven to be either true or false. For example, if you say, the bear is black, that is a proposition, but the statement the bear is X can't be true or false until a particular value for X is chosen, therefore, it is not a proposition.
What is Euler's method?
Swiss mathematician Leonhard Euler, 1707 to 1783, was one of the most prolific mathematicians who ever lived. He developed Euler's method, which is a way of determining the largest divisor of two numbers. For example, if we want to find the largest divisor of the numbers 6975 and 525, we consider one to be the large number and the other the small number.
What is a frequency table?
A frequency table is a way of summarizing data. In particular, it is a way of displaying how entities, such as scores, number of people, etc., are divided into intervals, and of counting the number of entities in each interval.
What is a mathematical space?
Outer space may be the final frontier to some people. But back on Earth there are also numerous types of space in mathematics. For the most part, mathematical space consists of points, sets, or vectors. Each space and the members of that space obey certain mathematical properties. Most spaces are named after their principal investigator, including Euclidean and Minkowski space. One of the most general types of mathematical spaces is called the topological space.
What are independent events in probability?
In probability theory, events are independent if the probability that they occur is equal to the product multiply together of the probabilities of either two or more individual events. This is also often called statistical independence. In addition, the occurrence of one of the events can give no information about whether or not the other event, S, will occur, that is, the events have no influence on each other. For example, two events, A and B, are independent if the probability of both occurring equals the product of their probabilities, or P, A, P, B. The symbol is often used to depict the product of the events in probability theory. One good example involves playing cards. If we wanted to know the probability of two people each drawing a king of diamonds, two independent events, it would be defined as A equals 1/52nd, the probability that one person will draw a king of diamonds, and B equals 1/52nd, the probability that the other person will draw a king of diamonds. Assuming the first person puts the first drawn card back into the deck. Substituting the numbers into the equation, the result is 1/52 equals 0.00037. Or a slight chance that both people will draw the king of diamonds from the deck.
Who was Scipione del Ferro?
There were several mathematicians in the 16th century who worked on algebraic solutions to cubic and quartic equations. For more information on cubic and quartic equations, see algebra. One of the first was Scipione del Ferro, 1465 to 1526. Who in 1515 discovered a formula to solve cubic equations. He kept his work a complete secret until just before his death, when he revealed the method to his student Antonio Maria Fiori.
What are some examples of paradoxes throughout history?
The oldest paradoxes may be from the Greek Epimenides the Cretan. Lived sometime during the 6th century BCE, who stated, "All Cretans are liars." If this statement is true and any other culture you would care to put in the Cretans' place, then the implication is that the statement is a lie. This is also called the liar's paradox. The number of paradoxes has continued almost ad infinitum since then. Some of the more popular ones include those listed as Zeno's paradoxes. They are named after Greek philosopher Zeno of Elea, c. 490–c. 425 BCE. A disciple of the philosopher Parmenides, who believed that reality was an absolute, unchanging whole and thus, that many things we take for granted, such as motion, were simply illusions. In order to defend his master's highly debated philosophy, Zeno developed his paradoxes. Most of Zeno's paradoxes are still highly debated by modern mathematicians and philosophers, thus proving another paradox: nothing truly changes throughout history, or does it?
What is a stomachion?
A stomachion is a dissection puzzle similar to a tangram. It uses 14 pieces in the puzzle, each of varying polygonal shapes and arranged into a 12 by 12 square grid. Each of the pieces has an area that is an integral fraction, for example, 24, 12, 9, 6, or 3, of the total area of the square, which is 144 units. The object of a stomachion is to arrange the pieces into interesting and often recognizable shapes, such as people, animals, and objects. This puzzle was also an ancient game known to the Greek mathematician Archimedes, c. 287 to 212 BCE, and thus is also called the loculus of Archimedes, Archimedes' box. It is doubtful Archimedes invented the puzzle, but he did explore its geometric aspects. It also now appears that in contemplating the different solutions to this puzzle, Archimedes actually was anticipating the branch of mathematics we now call combinatorics.
What is a caret?
A carat is a unit of measurement representing the weight of precious stones, pearls, and certain metals, such as gold. It was originally a unit of mass based on the carob seed or bean used by ancient merchants in the Middle East. In terms of weight measurement, a carat equals 3 1/5 grains troy. And it is also divided into 4 grains, sometimes referred to as carat grains. Diamonds and other precious stones are estimated by carats and fractions of carats. Pearls are usually measured by carat grains. For more about grains and measurement, see mathematics throughout history. Carats of gold are measured based on the number of 24ths of pure gold. For example, 24-carat gold is pure gold, but for a goldsmith standard, it is actually 22 parts gold, 1 part copper, and 1 part silver. As real gold is too malleable to hold its shape, 18-carat gold is 75% pure. 14-carat gold is 58.33% pure, and 10-carat gold is 41.67% pure gold.
What is Mohs scale of hardness?
Mohs scale of hardness, also seen as Mohs hardness scale, Mohs scale, or even erroneously as Mohs scale, was invented by German mineralogist Friedrich Mohs, 1773 to 1839. This arbitrary scale measures hardness or the scratch resistance of minerals and is often used as a quick way to help identify minerals in the field and laboratory. But the numbers assigned to the various minerals are not proportional to their actual scratch resistance. Thus, the main reason for using the scale is to know that a mineral with a lower number can be scratched by a mineral with a higher number. Although the Richter scale is mentioned most often in the media when a quake occurs, there is a more precise scale in use today that is based on the mathematics of motions caused by the earthquake. Called moment magnitude, this method uses a physical quantity related to the total energy released in the quake, which is called a moment. Seismologists can also deduce moment magnitude from a fault's geometry in the field or a seismogram reading. Scientists occasionally use moment magnitude when describing an earthquake event to the public. But because the concept is so difficult to explain, the number is often translated into the Richter scale.
What is the probability of drawing a diamond card or an ace from a pack of 52 playing cards?
The probability of drawing a diamond-faced card from a pack of 52 playing cards is easy to determine. Since there are 13 diamond-faced cards in the deck, the probability becomes 13 50 seconds 1/4 equals 0.25. The probability of drawing an ace from a pack of 52 playing cards is also easy to determine. There are 4 aces in the deck of 52 cards, thus, the probability becomes 4/52 equals 1/13 equals 0.076923. This represents a much lower probability than drawing a card in a specific suit, illustrated in the preceding example.
What is the new formula used for calculating wind chill?
Most people know about wind chill, the temperature your body feels when it is exposed to a certain air temperature combined with a particular wind speed. The higher the wind speed, the colder the wind chill temperature and the faster the exposed areas of a person's body will lose heat, a process known as transpo-evaporation. When moisture evaporates, the surface from which it evaporates loses some heat. The newest wind chill chart, called the wind chill temperature index, took over from the old chart. Developed in 1945, in the 2001 to 2002 winter season. The reason for the change was simple: the original wind chill index revolved around heat loss. With a standard set at the chill experienced while standing outside in air moving 4 miles, 2 kilometers, per hour. Based purely on temperature and wind and on how water freezes in plastic containers, the charts were developed in Antarctica by Paul Sippel and his fellow explorer, P.F. Passel. Back in 1939, partly with the intention of being used in World War II battlefield planning. Not everyone was thrilled with this simplistic, two-factor interpretation, however. There were pieces missing from the wind chill puzzle, such as the fact that humans constantly generate heat to the lack of wind measurements above 40 and below 5 miles per hour, 64 and 5 kilometers per hour. Passel and Sippel's wind speeds were also taken about 33 feet, 10 meters, above the ground, making the chart more valuable for a third-floor office than ground level. But the biggest problem overall was that the old wind chill chart could not accurately predict how humans perceive temperature. Thus, the new wind chill index was created. This chart includes such changes as wind speeds calculated at the average height of a human head, about 5 feet 1.52 meters above the ground. It is based on a human face model and sundry other more modern considerations. The actual general formula for the wind chill has now changed to the following. Wind chill in degrees Fahrenheit equals 35.74 plus 0.6215 T 35.75, V 0.16, plus 0.4275, V 0.16. In which T is the air temperature, in degrees Fahrenheit, and V is the wind speed, in miles per hour. The biggest difference between the old and new indexes is that the new index usually registers warmer temperatures than the old index. Still, no matter what the equation or chart, when temperatures are icy cold and winds are high, everyone should be careful and bundle up.
What is non-Euclidean geometry?
Non-Euclidean geometry is a branch of geometry that deals with Euclid's fifth postulate, the parallel postulate, that only one line is parallel to a given line through a given external point. This postulate is replaced by one of two alternative postulates. The results of these two alternative types of non-Euclidean geometry are similar to those in Euclidean geometry, except for those propositions involving explicit or implicit parallel lines. For more information about non-Euclidean geometry, see History of Mathematics.
What were some of the contributions by the Arab world to mathematics?
From about 700 to 1300, the Islamic culture was one of the most advanced civilizations in the West. The contributions of Arabic scholars to mathematics were helped not only by their contact with so many other cultures, mainly from India and China, but also because of the Islamic Empire's unifying, dominant Arabic language. Using knowledge from the Greeks, Arabian mathematics grew. The introduction of Indian numerals, often called Arabic numerals, also helped with mathematical calculations.
How is temperature measured?
Temperature is measured using a thermometer, thermo meaning heat and meter meaning to measure. The inventor of the thermometer was probably Galileo Galilei, 1564 to 1642, who used a device called the thermoscope to measure hot and cold. Temperatures are determined using various scales, the most popular being Celsius, Fahrenheit, and Kelvin. Invented by Swedish astronomer, mathematician, and physicist Anders Celsius. 1701 to 1744, in 1742, Celsius used to be called the centigrade scale. It can be capitalized or not. Centigrade means divided into 100 degrees. He used 0 degrees Celsius to mark the freezing point of water. The point where water boils was marked as 100 degrees Celsius. Because of its ease of use, mainly because it is based on an even 100 degrees. It is the scale most used by scientists. It is also the scale most associated with the metric system. Fahrenheit is the scale invented by Polish-born German physicist Daniel Gabriel Fahrenheit. 1686 to 1736, in 1724. His thermometer contained mercury in a long, thin tube, which responded to changes in temperatures. He arbitrarily decided that the difference between water freezing and boiling 32 degrees Fahrenheit and 212 degrees Fahrenheit, respectively, would be 180 degrees. The Kelvin scale was invented in 1848 by Lord Kelvin, 1824 to 1907, who was also known as Sir William Thomson, Baron Kelvin of Largs. His scale starts at 0 degrees Kelvin, a point that is also known as absolute zero. The temperature at which all molecular activity ceases and the coldest temperature possible. His idea was that there was no limit to how hot things can get, but there was a limit to how cold. Kelvin's absolute zero is equal to minus 273.15 degrees Celsius, or minus 459.67 degrees Fahrenheit. So far, scientists believe nothing in the universe can get that cold.
Who was Gregor Mendel?
Austrian monk Gregor Johann Mendel, 1822–1884, performed experiments with pea plants. From 1857 to 1865 that eventually led to his discovery of the laws of heredity. Gathering 34 different kinds of peas of the genus Pisum, all tested for their purity. He attempted to determine the possibility of producing new variants by crossbreeding. By self-pollinating the plants and covering them over so there was no unplanned cross-pollination, he determined the detailed characteristics of their offspring, such as height and color. Prior to Mendel, scientists believed that heredity characteristics of a species were the result of a blending process, and that over time various parental characteristics were diluted. Mendel showed that characteristics actually followed a set of specific hereditary laws. He worked out what can be described as a mathematical matrix of the characteristics, thus determining what characteristics were dominant and recessive in the plants. For more about matrices, see algebra. But Mendel had a hard time getting his results published. Even after publication by a local natural history society, his work was ignored. Mendel gave up both gardening and science when he was promoted to abbot. Coincidentally, and amazingly, by 1900 3 different biologists working in 3 different countries, Hugo de Vries in the Netherlands, Erich Tschermak von Seisnig in Austria, and Karl Correns in Germany, determined the hereditary laws independently. But they all knew about Mendel's work, graciously giving the credit for the findings to him. Mendel, rightfully, is now commonly considered the father of genetics.
What is an angle?
An angle is a major concept in both geometry and trigonometry. An angle is formed by two rays that begin at the same point. A straight angle is one in which the two rays lie on the same line. It can also be described as two planes coming from a common line. Angles are named in several ways: a capital letter at its vertex, the common points for both rays. See illustration, LB, a small letter within the angle, a number within the angle, or by three capital letters. ABC or CBA, with the middle letter representing the vertex and the other 2 points the rays. The two rays that form the angle are called the sides of the angle, such as side BA and side BC.